Hello everyone, welcome to the new course which is the summary of the Geography Classics NCERT. This is presented by me Arpita Prakash. You can read more about me from here. You can also rate, review, recommend and share the lessons if you are liking them. You can also follow me on Unacademy at this given user link. Let's begin. This is the first lesson on the Earth in the solar system. Now, what the first term we are understanding is celestial bodies. What do you mean by this term? These are also known as heavenly bodies. Now, this word celestial or heavenly relates to anything that is present in the universe. So, anything like whether it's like matter or energy or space or anything that is found in the universe is known as celestial bodies or heavenly bodies. Some examples: sun, moon, star, planets, anything. Okay, now what are stars? They are like very big, huge in size, they are very hot and they are burning ball of gases. They have their own heat and light, very important, own heat and light. They emit them, reflect them. Then they have great mass. So size also it's great, and then mass also they have like huge mass. And then they have gravitational force. What is this? Which is used to attract the other objects in the sky towards their center. If this is the star, this is the center, it will attract other objects towards them because of the gravitational force. Then some example is like sun is also a star. We see many stars twinkling in the sky in the night, but then this is very important to know that the sun which we see during the day is also a star. Now, why do stars twinkle? See what happens, suppose we are standing here on the earth and the star is here. So, the earth is surrounded by atmosphere, that is gases, layer of gases. So, when the star, the light from the star passes, reaches the earth, it passes through this atmosphere. Different gases are present here in different layers which have different density. So, if the layer will have like more density, the light will take more time to pass because it will be like more dense, so it will take time to reach to the other level. And if it will be less denser, it will take less time. So because of that, it keeps on like fluctuating, not exactly, but it seems to be fluctuating, and that is what is twinkling. This is because we see that, this is why we see that stars twinkle, fluctuates. Now this is a small input. What is astronomy? This is a branch of science that deals with the study of sun, moon, star, planets, etc. And who is known as the father of astronomy? Nicholas Copernicus. Very important question, like 1 mark question. It can be asked in any of the exams in MCQ. Then galaxies. So the stars which are found in groups are known as galaxies. So that group is known as galaxy. The solar system is a part of Milky Way galaxy, which is also known as Akash Ganga. Now, the galaxy which is closest to Milky Way galaxy, please remember this name, known as Andromeda. Now, what is this nebula? Suppose this is one galaxy, this is another galaxy. So, between these two group of stars, there is also another group or cloud, you can say, which is of like gases and dusts. Here, the different new stars also are born, and then they might, combine with the existing groups. So, the existing groups of stars are already known as galaxies, and this cloud of gas and dust is known as nebula. Then this is like Milky Way galaxy. Here we have our solar system. It is spiral in shape, also known as Akash Ganga. Then constellation. It is also a group of stars, but it forms an imaginary shape. So, this is different. It forms a shape. When we look at them, we see that it might resemble a certain shape. Now, one such example is Ursa Major constellation, which is in Latin, and in English it is known as Big Bear constellation. So, one part of this Big Bear constellation is Small Bear constellation, which is also known as Big Dipper. In Sanskrit, it is known as Sapta Rishi. Sapta is 7 and Rishi is sages. So, it is a group of 7 stars. It's like easily traceable in the night sky. You can ask your elders also. You can yourself also see them. So, this is a group of 7 stars. Now, suppose if you look through these two stars in line are known as pointer stars. So, when you look through them, they point towards a star which is known as pole star or north star or Polaris. Now, this star was still used, but now the technology is so much developed. Earlier, when the technology was not much developed, so the astronomers used this star to know the direction because it always points in the north direction. Now, the solar system, This is made from the word solar, which is again made from the Latin word sol, which means sun. So it is the family of the sun. It comprises of the sun, the 8 planets, satellites, other celestial bodies. Now what is this cosmic year? So the time the solar system takes to orbit around the galaxy, Milky Way galaxy, we have seen that it is a part of Milky Way galaxy. So the time it takes to orbit around this Milky Way galaxy is known as cosmic year, which is about 26,000 years. Then what is sun? It is huge in size. It is made up of gases. So it is like very hot. It is also known as yellow dwarf. It is a part of Milky Way galaxy because it is a part of solar system, and then it is the closest star to the earth. Then it is in the center of the solar system, ultimate source of heat and light for the solar system. Distance wise, it is about 150 million kilometers away from the earth, and then light from the sun takes about 8.5 minutes to reach earth. So it is somewhere you'll see it's written 8.5 minutes or 8.4 minutes or about 8 minutes. So it's similar. I mean, you cannot just calculate the exact time. So it's like about 8 minutes to reach to the earth. Now the closest star to the sun. Sun is the closest star to the earth, but then the closest star to the sun is known as Proxima Centauri, which is about 4.22 light years away. Now what is this light year? The distance that light travels in a year. So it's very easy to remember, the distance taken by the light to travel in a year. Now what is the speed of light? Because we calculate distance with the help of speed. So what is the speed? 3 lakh kilometer per second. Now the composition of sun is 71% of hydrogen, 28% of helium and 1% of other gases. These are the approximate composition. Now, what are planets? Made from the word, derived from the word Greek word planeti, which means wanderer. Wanderer means who keeps on moving from one place to other. It is also celestial body found in the solar system. It does not have any heat and light of its own. So it's like no heat and light of own. It reflects sun's light, and it revolves around the sun in fixed paths, which are known as orbits, and these are like elliptical in shape. You can see here it's oval shaped. Then there are 8 planets in order of their distance from the sun. Like Mercury is the nearest and Neptune is the farthest, and Earth is the third nearest planet to the sun. So you can see Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. You should remember their names. You can have your own mnemonics also. You can use them. Now, till 2006, Pluto was also considered as a planet, but then later IAU, tell me the full form of IAU in the comment section below. It was decided that now the Pluto will be considered as dwarf planet and not among the major planets. So it's just 8 now. Now, what are the inner planets or the terrestrial planets or the rocky planets? The name suggests that they are made up of rocks. They are very close to the sun. So there are 4: Mercury, Venus, Earth, Mars, which are the inner planets. Then the outer planets, the other 4, Jupiter, Saturn, Uranus and Neptune, they are the outer planets or the gaseous planets. So they are made up of like gases or liquids. They are also known as Jovian planets because they are very similar to Jupiter. So they are the huge planets and far away from the sun. Then Earth, this is the third nearest planet to the sun. We have seen Mercury, Venus and then Earth. Then its shape is known as geoid. This term was coined by J.F. Listing. What is geoid? It means uniquely earth shaped, or this is the unique shape of the earth. So it's earth like shaped. It bulges. It's like, little extension is there to, near the equator, and then a little flat at the poles. So it's not complete sphere. It's like little flat here and little bulge here. Then it is unique planet because life exists only on Earth. Why? Because we have an atmosphere which envelops the Earth, which has gases like oxygen and ozone. We have water, which like forms 3/4 of the surface. So whenever we see from outer space, it's like completely blue, blue and blue. So it is known as blue planet. It exists in these 3 forms: liquid, solid and gases. Then the temperature is neither too hot or not too cold on the Earth. We have like kind of moderate temperature so that life can exist. Then what are satellites? These are also the celestial bodies. Now they revolve around the planet. The planets revolve around the sun, and the satellites revolve around the planets. They shine by reflecting the light of the sun. So they do not have their own light, and they are like natural also, man-made also. So for Earth, the natural satellite is moon, and some man-made satellites or the artificial satellites, they are basically designed by the scientists so that they can gather information about the universe. So they carry these satellites on a rocket, they leave them in the space, and then they gather information about the universe. They are placed in orbit around the earth. Some example of Indian satellites: INSAT, EDUSAT, etc. Then moon, its diameter is about 1/4 of the size of the earth. So you can say it's like much smaller in size, but it appears big to us. Why? Because it is comparatively nearer to us than any other celestial body. It completes one orbit of earth in about 27 days and takes the same time to complete one spin, that is rotation on its own axis. Then it also has some like mountains, craters. Craters is basically kind of depression, valleys and other landforms, and they like form shadow on the moon surface. So sometimes you might see also, a light of patches on the moon. So on the white moon there are some yellowish or brownish patches kind of thing. So these are these are the shadows because of these formations. Then there is no water or no air on the moon, so the life does not exist there. Then when there is like full moon or Purnima, it is when the moon is fully lit by the light of the sun. So it is like full moon, this complete moon or Purnima, and when the moon is completely dark, the light does not reach there. So it is new moon or Amavasya, so it's completely dark moon. Now some interesting facts: who was the first man to step on the moon? Neil Armstrong from United States. And India's first successfully launched moon mission was Chandrayaan-1. You should know these names. Then what are asteroids? These are the tiny rocky bodies which are found between the orbits of Mars and Jupiter. Important is between Mars and Jupiter, so found here. Then they orbit around the sun because they orbit along with the planets. They are just found between the orbits of Mars and Jupiter. Now what are meteorites? They are small pieces of rocks, like kind of flying objects. They also move around the sun, but they are found outside the Earth's atmosphere, and they sometimes come near the Earth. Now there are different terms: meteors and meteorite also. This was meteoroids. See here. Now, what is meteors? These are the meteoroids which pass through the Earth atmosphere. So they are found like outside the Earth atmosphere. They pass through the Earth atmosphere, and then because of friction with air, what happened? They get heated up and they start burning. So they cause a flash of light. So they are also known as shooting star. So they are like passing through the Earth's atmosphere. Then meteorite, these are like, they also pass through the Earth's atmosphere and then falls on the Earth's surface. So they create hollow or crater. If they will fall, they will have some pit kind of thing, crater or hollow, and they mostly contain iron. So the other thing is comets. They are the icy bodies of gases and dust. The important thing is they have like long tail kind of thing. They also orbit around the sun. So the best known comet is Halley comet, which was last seen in 1986 and which is most likely to be seen next in the 2061 years. In human lifetime, basically only this is the possible. Then spectroscope, which is like a special instrument used by the astronomers to find out whether the object is moving away from the Earth or towards it. So they use this instrument to see this. This is known as spectroscope. Now this is the important figure. So here are the 8 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus and Neptune. This is the sun. This is the moon, the natural satellite of Earth. You can see between the orbits of Mars and Jupiter. Here this is the asteroid belt. So they are found here. Then they also have like meteoroids and the comets. You can see this long tail here in the comets. So this is basically about this is the figure of the solar system. Earlier Pluto was also considered a planet. Now it is considered a dwarf planet. So now this was whole about this lesson about the Earth in the solar system. Earth in the solar system. I hope you liked the lesson. If you did so, please rate, review, recommend and share the lesson. Alright, I'll see you in the next lesson. Please do visit the overview also. Now thank you so much. Bye bye. Take care. Hello everyone. Welcome to the new lesson on the course, which is the summary of Class 6 Geography NCERT. This course is presented by me, Arpita Prakash. You can read more about me from here. You can also rate, review, recommend and share the lessons if you are liking them. You can also follow me on Unacademy at this given user link. I'll just request you please go to the overview lesson also before doing all the other lessons, because I have told something there in the overview lesson, which some points which are needed to be considered, and I cannot repeat them in every lesson. So please first visit that and then only start from the other chapters. Let's begin. This is the first part of the second lesson, which is on latitude and longitude. Now, before we do this, let us understand something about globe. What is this globe? It is derived from the Latin word globus, which means a round body or a sphere. So, round body or a sphere. Now, what is a globe? In general also we know this, that this is a model of the earth. It represents the earth in a much smaller way, but it considers all the other themes, like all the other components of the earth, like continents, oceans and everything, and it presents them. Now, it contains a few things. We will be dealing in the details of all these things later, I mean as we proceed with the lesson for the time being. So, it deals with geographic coordinates like parallels, meridians, or you can say the latitudes and longitudes, which are used to locate places on it. It also has an axis. What is axis? An imaginary line about which a body or globe rotates. So, you know that if this is a globe, here is also a line along which you can spin the globe. So, that is like the axis, and the axis is in tilted manner, not straight but tilted manner. Now, it also has 2 points, North Pole and the South Pole. So, this is the rough figure of the globe. I have just tried to make this. This is the globe which is in inclined position. This is inclination. This is the North Pole, this is the South Pole. This is the axis, this particular thing, because this is the frame. So, here the axis is joining the North Pole and the South Pole, and we spin the globe along this axis. Geographical coordinates are like the parallels and the meridians. So, when you join them, they form a network kind of thing, and you can locate any place easily on the globe. Now, what is this axis of the earth? It is an imaginary line. It is tilted in nature, not straight but tilted, and the tilt in the earth's case, it is known as obliquity, because it is a moderate tilt. It is not very extreme, it is moderate tilt, a slight tilt is there. Now, you have to learn about the angles. This is very important. They can be asked in MCQ kind of thing. Don't just think that this is class 6, so this is not relevant. This is very, very much relevant, because the small details, minute details, we tend to forget while we are appearing for the exam. So, they can ask you, they can give the angle, and they can ask that the axis makes which angle, I mean what degree of angle with which line. So, you have to remember that. Now, just see here, this is the axis and this is the equator. See, it's tilted, so it's like this. Now, this is the equator and this plane is known as equatorial plane. But this is the orbital plane. Orbit is what? The earth revolves around the sun in an orbit, elliptical orbit. We have just seen that in the earlier lesson. So, this one, this dotted line here, this is the plane of earth's orbit or the earth's orbital plane. So, this axis is making an angle of 66.5 degree with the earth's orbit, I mean the plane of the earth's orbit. But the same axis is making an angle of 23.5 degree with this line. And what is this line? The vertical line from the earth's orbital plane, or the perpendicular line, which is making 90 degree with this plane. So, this line is making 90 degree with this plane. So, the angle between axis and this line is 23.5 degree, and the angle between axis and this is 66.5 degree. Just remember the angle corresponds to which of the plane we are talking about. Now, there is something, parallels of latitude. Before we do parallels, we will see what is latitude. Latitude are not these lines. These are the parallel lines, not the latitude. What is latitude? It is the angular distance measured north or south of the equator. Now, this is equator at 0 degree. So, the angular distance, that is the distance measured in terms of angles, north and south of the equator. I have just covered the northern part here, so that it does not become so hodgepodge kind of thing. So, I'm so sorry. Yeah, it's 0 degree here, 90 degree here, North Pole, equator. So, between them, it's like 10 degree, 20 degree, 30 degree. Now, how do we measure that? Suppose you have to first imagine it to be a 3D figure, right? Because I cannot explain in that way. So, I have tried to draw it like that, but it is not completely visible. So, please imagine it to be a 3D figure or kind of a ball in your hand. Now, see, this is the center of the earth, the interior. Now from here, if we take a point on any part of the globe, suppose we take a point at here on the earth or the globe, you can say. So when we measure the distance between this point, and in the terms of angle, that this point is located at what angle from this point, that is the latitude of this place, and then we say that it is at 10 degree north latitude. Similarly, these other degree are here. So if there is any place, suppose this is the 10 degree north latitude covering the entire earth, you have to imagine it is a ball here and we are like surrounding it with a line. So even this place will be at 10 degree north latitude, this place also, when we measure from the center of the earth. So all places on the same latitude will have like the same angle. This is the main thing. Now what is this parallel? These are the lines connecting all points on the same latitude. This is what I have said. If this is a latitude and here are different points here, so when we join all these points, it becomes a line which is a parallel line. Parallel to what? Parallel to all other latitudes. If we draw like this, we draw like this, we draw like this. Basically what is parallel? Two lines which have like equal distance between them, right? So parallel means two lines where the distance does not decrease or increase between them. So they are parallel to equator and all other latitudes, and they are the circular lines, complete circle. They are in the east-west direction. The distance between two parallels is always equal, and they reduce in length and increase in value till they converge at a point. So we can see here the value is increasing from 0 degree to 90 degree as they are converging. What is converging? Just meeting at a point here. So as they are converging or moving towards the poles, the value increases but their length decreases. This equator has the largest length. Why? Because it is in the center. So it has the greatest circumference, and then the length keeps on decreasing. Distance remains the same, value increases but length decreases. Now, the equator is the largest of all circles. It is also known as great circle because it covers a circumference which is like 360 degree, the entire circle, and it divides the earth into two equal hemispheres. What is hemisphere? When a sphere, a circle kind of thing in 3D structure. So when a sphere is divided into half, hemi is half, northern and southern. So this is northern and this is southern. And then the parallels are measured between 0 to 90 degree, both north and south, and 1 degree latitude is about 111 kilometer. Now some important parallels of latitude: equator, Tropic of Cancer 23.5 degree north, Arctic Circle 66.5 degree north, North Pole 90 degree north, Tropic of Capricorn 23.5 degree south, Antarctic Circle 66.5 degree south, and this point South Pole 90 degree south. Now heat zones of the earth, we have to understand that, see, this is the sun and the rays are coming from the sun on this earth. Different latitudes are here. So the vertical rays of the sun just comes here, and as we move towards the pole, the rays become slant in nature, slight, deviated, not the vertical, not the straight lines. So we have to understand that all parts of the earth are not going to receive the same amount of sunlight. This part will receive greater amount of sunlight with greater intensity, and as we move towards the pole, the intensity as well as the amount of sunlight decreases. So this is what is here. It is based on the vertical and slanted rays of the sun, because all parts of the earth do not receive equal amount of heat from sun. So the earth is divided into 3 heat zones depending on the amount of heat they receive. The vertical rays of the sun do not go beyond the tropics. The vertical rays are limited till the tropics itself, Tropic of Cancer and Capricorn. Beyond that, it decreases. Then the 2 tropics represent the farthest limit of the sun's vertical rays. This is the figure. What are the 3 zones? These are the 3 zones: torrid or the tropical zone, temperate zone and frigid zone. I'll just show you here. This is the torrid zone, these are the temperate zone, and these are the frigid zone. Details: torrid zone is dry and hot because the direct rays fall between 23 degree north and 23 degree south, 23.5 degree north and 23.5 degree south. The sun is overhead at noon. Direct rays of the sun fall and it remains hot throughout the year. Temperate receives moderate heat. These are the latitudes, and the sun is never overhead beyond the tropics and the angle decreases towards the poles. Frigid is the coldest zone, and these are the areas. You can see from here also the degrees are mentioned. Then what are meridians of longitude? So literally the word meridian is like meri and dian. So meri is the time when the sun is at the highest position in the sky, that is the noon time, and dian is day. So basically meridian technically or literally means the time, that time of the day when the sun is at the highest position in the sky, or the noon time. And in terms of like this latitude and longitude, how we describe, these are the semicircles which run through the north pole and the south pole. Here's the north pole and south pole. So the semicircle, the half circles, and they cut the equator at right angles. So they run like this and equator is like this. So they make a 90-degree angle, and they are all equal in length. Like the parallels, they were not having equal length, they were decreasing as we move towards the poles, but here since they join the two poles, they are equal in length and they converge at poles, right? They converge, they meet here at this pole, and the distance between two consecutive meridians, the two meridians, is maximum at the equator, and the distance decreases toward the poles because they converge towards the poles, and they are measured like from 0 to 180 degree, both east and west. Here it's not north and south, it's east and west. Now what is this prime meridian? Prime is the main thing, like prime minister, the main person. So it's like the prime meridian, the main meridian. It is that meridian which passes through Greenwich Observatory, which is located in London. Measurement is 0 degree. It is also known as Greenwich meridian because it passes through here, and it divides the earth into two hemispheres again, the eastern and the western, and the equator divides into northern and the southern. Then what is this longitude? It is similar to latitude, the angular distance of a place. The only distance is measured east or west of the prime meridian, and that was measured north or south of the equator. But the common thing is the angular distance measurement. Now the maximum distance between two meridians is maximum like at the equator, this I have told you, and then 0 degree and 180 degree are common to both the hemisphere. Like when we start from here 0, we move towards 180 degree here, and we move towards 180 degree here in the west and here in the east. So these western line and eastern line are the same, the common line, 0 to 180, 0 to 180, and then since it's a circle, so it's the same line opposite to 0 degree. Now this is the just figure, this is the equator, these are the different meridians at different angles. This is the prime meridian at 0 degree, and then this 10, 20 and similar 10, 20 here. So 0 to 180 will go here, 0 to 180 will go here, and that 180 will be opposite to this 0, and that will be same for both eastern and western hemisphere. Now what is this? Grid. What is grid? It is network of lines which cross each other. So horizontal and vertical, that is parallels and meridians. Horizontal is this, the parallels, and the vertical is this, meridians. So when these meridians and these parallels, they intersect each other, this forms a network or the grid. So they intersect at right angles 90 degree, and they help us to locate any place. If I tell you that this is the longitude of a particular place, this is the latitude of a particular place, you can easily locate that place on a globe or a map, anything. So this helps in the location of a particular place. Now this was all for today. We have another part of the same lesson number which is on time. We'll be just dealing with that. I hope you are liking the lessons. If you are doing so, please rate, review, recommend and share. Thank you so much. See you in the next lesson. Bye-bye. Hello everyone. Welcome to the new lesson on the course, which is the summary of Class 6 Geography NCERT. This course is presented by me, Arpita Prakash. You can read more about me from here. You can also rate, review, recommend and share the lessons if you are liking them. You can also follow me on Unacademy at this given user link. Now, this is the part 2 of the same lesson. The earlier one we discussed about the latitudes and the longitudes. Now, here we are talking about the concept of time. Technically, this was to be included in that one only, and even I tried doing it. So, I had to re-record all these lessons again because the time did not allow me to finish all these things in one lesson, which is maximum of 15 minutes. So, I couldn't cover, and this is like really important topic. Not just from considering that it is mentioned in class 6 book, it is very important for UPSC examination also. So please focus here. This is about the concept of time, both about the Indian Standard Time as well as the International Date Line. So we will just see how it happens. Now You know that the circumference of the earth is 360 degree. We consider it to be a sphere, although it is not exactly spherical in shape. We have seen what is the shape of the earth known as. Just write down in the comment section. I have given you that particular word, the term. Now, since the circumference is 360 degree, so I'll just show you how it is divided, how it is used to calculate time. We will just focus here. 1 degree is equal to 60 minutes. This is the symbol used, and then 1 minute is 60 seconds. So for the time, we just remember this, and the circumference of earth is 360 degree. Then this is about local time. Before we start, what is local time? Now see here. Earth completes one spin or rotation in 24 hours. We know this. Earth spin on its axis in 24 hours, one day. Now, so that means the circumference is 360 degree. So this 360 degree is covered in 24 hours. This is what it means. If 24 hours takes like 360 degree to cover, then in 1 hour how much degree is covered? 15 degree. 360 divided by 24. So 1 hour is equal to 60 minutes. So 60 minutes is used to cover 15 degree. If 60 minutes is used to cover 15 degree, 1 minute is used to cover 1/4 of a degree. We are just dividing, its unitary method. I mean, you should know this, right? You just try to understand this. So if 1 minute is required to cover this much degree, how many minutes are required to cover 1 degree? It will be 4 minutes. So 1/4, 1 minute, then 1/3, 2 minutes, and similarly it will be like 4 minutes required to cover 1 degree. Now, this is very important to remember that, just see here again, 1 hour 15 minutes and 1 degree 4 minutes, because we need to study the time zones and this is required there. Remember this, just feed that in your head. Now, the earth rotates from west to east. Remember the direction also. Now, what is this local time? It is that time when the sun is overhead, directly overhead, right? And it is the time which is the noon time, because the sun is directly overhead and the shadow cast by the sun is the shortest. Why? Because the sun is overhead, the shadow will be in the minimum size. So the time, whenever we like, how do I explain? Okay, I'll tell you like this. Suppose we are living in like India, so everyone, wherever we live, in any of this state, we follow the same time, right? Our clock, our watches have the same time. So how does this happen? We calculate the time considering a local time, not just we, anywhere it is calculated according to the local time. We just consider one time which is especially the time when the sun is overhead, that is a noon time. So from there we start calculating the other times, so that there is uniformity in time, there is not a difference in time, because if one part of the country will have another time and the different part will have a different time, there will be ambiguity whenever you move. However, there are exceptions, we'll just see that. Now, when the prime meridian, which is at 0 degree, the Greenwich meridian, has the sun at the highest point in the sky, then all the places which are located on this particular longitude, that is the prime meridian, will have the same time, that is noon. So this is a general rule that every place on the same meridian, suppose this is one meridian, be it prime meridian or any meridian, so all the places that are located on this meridian will have the same time. So you have to remember this. Since the earth moves from west to east, the places which are east of, this is the Greenwich or the 0 degree prime meridian, so the places which are east of Greenwich will be ahead of Greenwich time. What is ahead? It means, suppose the earth is moving like this from west to east. So the place and the prime minister, see here, the not the prime minister, the prime meridian is here, and any place which is east of the prime meridian is here. So this is 0 degree and the earth is moving like this. So the earth, this place will receive sunlight first and this place will receive sunlight later. There will be a difference of time between these two. So the place which is east of the 0 degree will be ahead of time as compared to the places which are behind. So the places which are like west of 0 degree will be behind of time and the places which are east of Greenwich will be ahead of time. Now, this is a concept of standard time. Why? Because the local time might differ from place to place. This is what I told you. There can be ambiguity, so we need to have a standard time. And the larger areas can have more than one local time. You know, it might be needed that, because if the area is very large, so there will be difference in the time zone. Now, to follow a uniform time throughout a country or any region, how we take this standard time, we do this based on a central meridian of the country. So, if this is a country and there is a central meridian here, or the meridian on which the most important city is located. So, we choose a meridian which is either in the center or very like important city passes through that meridian, or, and the other condition is that it should be a multiple of 7.5 degree. Why 7.5 degree? Because we just saw that 15 degree is like being covered in 1 hour. So, it is like 7.5 degrees, it is a multiple of half an hour. When we see the time zones, you will understand why this 7.5 degree is important. So, how the time zone is divided? The earth is divided into 24 time zones which is of 1 hour each. So, 1 hour each, that means 15 degree each, 15 degree longitude each. Now, the large countries like Russia, this is the largest country by land mass, you should know this. So, the large countries, they have large longitudinal extent, starting from here and ending here. So, all the places, like there are different time zones also, because we cannot use one time zone because they have like huge longitudinal extent. So, they have more than one time zone, like Russia has 11 and US has 4, but for India we just have 1. Now, this is about Indian Standard Time. Our longitudinal extent is 68 degree 7 minute east to 97 degree 25 minute east. So, we like kind of middle meridian we have taken between these two extent. So, the central meridian comes out to be 82.5 degree east, which is the the meridian for Indian standard, used as Indian Standard Time. This is the meridian considered the central meridian, and this is east of Greenwich. Like Greenwich is here 0 degree. So, R1 this 82.5 degree east is 5 hours 30 minutes ahead of the Greenwich meridian time. So, that means if it is noon at GMT, if it is like 12 mid noon at GMT or the Greenwich meridian time, at India it will be 5:30 PM because it is ahead by 5 hours 30 minutes. And similarly, you can take any time at GMT and then any time depending on the this number, like the difference 5 or 30 minutes, you can calculate what time will be there in India. Now, this is the thing, this is the extent I was talking about, 68 degree 7 minute east to 97 degree 25 minute east, the longitudinal extent, and this is the central meridian of India, which is 82 degree 30 minute east. Now, there is one concept of international dateline, very important. What is it? Now, we have to remember again that the earth is divided into 24 time zones, 1 hour each, and 1 hour is like 15 degree of longitude. Now, this ideal international dateline is an imaginary line which is internationally agreed upon. Then it is, the location is 180 degree meridian. So, we also studied in the previous lesson that the 0 degree, when we move from 0 degree to 180 degree east and 180 degree west, so this 180 degree is the common line, the same line. So, this is what is known as the international dateline. Why is this special? Because you'll just see there is some exception in this line. There are some deviations when this line is drawn. Usually, you can see that all the lines are drawn like very straight, but this line is like zigzag. Why? I'll just tell you. Now, when we move from west to east, there is gaining of a day when we cross ideal. So, these are like very important key points. While crossing international dateline 180 degree, when we move from west to east, there is gaining of a day. When we move from east to west, there is loss of a day. How it will happen? Again, I'll show you the figure. It's in the middle of the time zone. So, this is one time zone. Here is the international dateline. So, it's like middle. This whole time zone will have 15, like 1 hour, so 15 degree longitude. So, the half hour will be 7.5 degree. This is what I told you earlier also. Just see here. I told you here. Yes, 7.5 degree, half an hour. So, this was the reason. And when we cross ideal, what happens to date and time? We will just see here. Now, see, this is 0 degree, the prime meridian. This is when we move from west to east. This is 180 degree east, the international dateline. And similarly, when we move from east to west, This is also the international date line, the 180 degree west, and these two lines coincide. Just try to imagine it to be a circle. This is a flat paper, so it's like two lines are visible here, but when it's a circle, here is 0 and the opposite one is the 180. So when we are moving from west to east, we are gaining a day. That means if at 0 degree it is 1 p.m. and the day is Monday and the date is 1st January. So when you will cross this ideal, what happens to we are gaining a day. So the day becomes like one extra. From Monday it becomes Tuesday while crossing, remember this line. And the date is like 1st January to 2nd January and the day becomes extra, one more. So we are like gaining a day. But the time, see, it has like 12 time zones here and 12 here, because in total it is 24. So 1 p.m. and then 1 a.m. The difference is of 12 hours, 12 time zone, 1 hour each. So the difference is of 12 hours here. So we are gaining a day and here we are losing a day in this context. So this is like 2nd January, this is like 1st January, and this is Monday and this becomes Tuesday, but the time between them is the same. We are talking about the same line. You have to imagine it to be a circle. I am repeating again, this is a circle, so this is one single line. The time is same, but the day is here, it is at the loss of one day. Here we are gaining one day while we cross this line. Hello everyone, welcome to the new lesson on the course, which is about the summary of class 6 geography NCERT textbook. This course is presented by me, Arpita Prakash. You can read more about me from here. You can also rate, review, recommend and share the course if you are liking the lessons. You can also follow me on Unacademy at this given user link. Now this is the third lesson. We have already done 2 of them, and the second lesson also had 2 parts. So it's like 3 of them here, and this one is in number it's 3, but it's the 4th lesson here. So it is on the motions of the earth. Now 2 types of motions of the earth are there, basically rotation and revolution. The first one is rotation. What it is? It is the movement of the earth on its axis. So it spins or it rotates on its own axis. We know that the axis of the earth is tilted, slight tilted. So the earth rotates on that axis. Now it takes 24 hours for one rotation, and it is also known as earth day. So for us, one day is equal to 24 hours because this is the time that the earth takes to rotate on its own axis. Now because of this rotation, what happens? Days and nights are caused. How? We will just see. And it moves from, this rotation takes place from west to east, that is in the anti-clockwise direction. It takes place like this. Then the inclination of the earth's tilt, it's making an angle of 66.5 degree with the orbital plane. We have already covered that in the earlier lessons also. If this is the earth axis, this is the orbital plane. So the angle here is of 66.5 degree. This is also known as inclination of earth's tilt. However, this word axial tilt is different from this inclination. Axial tilt is known as obliquity. I have told you. This is like making 20.5 degree angle with the vertical line to the orbital plane. So this is the axis, this is the orbital plane. So this is 66.5 degree. This is known as inclination of earth's tilt, and this axis and this vertical line to the plane. So this angle is 23.5 degree, which is known as axial tilt. So difference between these two words, you cannot just say that inclination and tilt or the axial tilt is the same. Now the circle that divides the day from night on the globe, if this is the globe, half part is like if day, half part is night. So this circle or the line that divides this day, this globe into like day and night, half, this is known as circle of illumination. This is the figure. The rays are coming from the sun. This is the equator at 0 degree. This is the tilted axis, North Pole and South Pole. The earth is moving from west to east. So this half part is receiving this day sunlight. So this is day here, and then the other half is not receiving. So it is night here. So this line of division is the circle of illumination. Now because of this, what happens? That the half of the earth is receiving the sunlight and the other half does not receive. There is unequal heating because the vertical rays fall only over the equator. You can see the direct vertical rays are falling over the equator, and as we move towards the poles, what happened? The rays start becoming slant. So they are the slanting rays towards the poles, and the tilted axis, this tilted axis is always pointed towards the pole star. So this also shows the direction, pole star, or the which is in the northern direction, the north star. So this line also shows the direction. Now the other motion is revolution, that was rotation, spinning on its own axis, taking 24 hours per rotation. This is revolution, which is the movement of the earth around the sun. So this is the sun, the earth is moving in an elliptical orbit, this oval shaped orbit. It takes about 365 and 1/4 of day, that is 365 days and about 6 hours. So for us, for our convenience, 1 year is considered to be of 365 days. And what happens to this 1/4 day, or like 6 hours? It is added to the February month every 4 years. So in every 4 years, we add 1 day to the month of February. You know this, so that the days become 29, and it is also known as leap year. So you are going to tell me in the comment section which is the next leap year coming, and how do we identify, just looking at the year, how do we get to know that if this is a leap year or not? You have to tell me that. Okay, now because of this revolution, what happens? Change of seasons. So basically we have 4 seasons: summer, winter, spring and autumn. So we will see how this happens. Now the seasons in the northern, these are some points to remember so that it helps in the clear understanding of that changing of seasons. Seasons in the northern hemisphere are reversed to that of the southern hemisphere because of the amount of sunlight being received, and then because of changes in position of the earth, which like while revolving around the sun. So there is this change in the seasons in the northern hemisphere and the southern hemisphere. The intensity and duration of sunshine goes on changing towards the poles. So it is like very direct and vertical and very intense when it comes to equator and this tropical area, but as we move towards the poles, it goes on decreasing. Now we have to study 2 words to understand this entire concept of changing of seasons. The first is solstices and the second is equinox. So what's this solstices? That time of the year when the sun's vertical rays fall over one of the 2 tropics. So the earth has 2 tropics, Cancer and Capricorn. So it is that time of the year when the sun's vertical straight rays fall on any one of the tropic, either Cancer or Capricorn, directly over any one of the tropic. Then the sun appears to stand still. This basically means, in normal sense we can say, that the sun appears to stand still. Why? Because it has reached its highest point in each hemisphere. We have already studied that a tropic represents the highest point of the sun's vertical rays. So in each hemisphere the sun has finally reached its highest point, and that is the tropic of the Cancer or the Capricorn. So it is that time of the year. So these are the 2 tropics. Now the 2 solstices. The first is summer solstice, which is observed like on 21st of June. What is it? In this, the northern hemisphere is tilted towards the sun. Now see here, this figure is very, very important. You have to like completely focus here now. See, this is the sun. These are the different seasons we are talking about. We are starting from this summer solstice. Now what is this on June 21st? What is happening? The northern hemisphere is tilted. See, the earth is tilted here. What is happening? This is equator. So this is the northern hemisphere. It is now tilted. See, it is tilted towards the sun. So major portion of the northern hemisphere is receiving the heat. However, in southern hemisphere, you see the south pole, it is completely out of this sun's heat. It is not at all receiving. It is in the dark. It is not receiving. But this north pole, it is receiving, and this northern portion hemisphere is tilted. So the northern hemisphere is tilted towards the sun, and the sun's rays is directly falling on the tropic of Cancer. So it is receiving more heat. See, the sun's rays is directly falling on the tropic of Cancer. This red line here, you can see, directly falling. So this area is receiving more heat, and the area near the poles are receiving less heat because of the slant rays. So there is summer in the northern hemisphere because the major portion of the northern hemisphere is receiving heat. So it is summer in the northern hemisphere and India is in the northern hemisphere. So we know that in the month of June we usually have this, we have this summer. Sometimes monsoon also starts there. So the areas beyond Arctic Circle, it is like continuous daylight for about 6 months. So areas beyond the Arctic Circle, mean this narrow portion, So what happens? This is completely under the sunlight. You can see it's white here. It's not darkened. So this area, it is like receiving continuous daylight for about 6 months. Although the intensity is less, the heat is less because of the slanting rays, but daylight is there. So on 21st June, we have longest day and shortest night. So you have to remember summer solstice, 21st June, longest day and shortest night. And in the southern hemisphere, the entire thing is reversed. They have winter, they have longer nights and they have shorter days. This was summer solstice. This is winter solstice, the opposite. We are considering from the point of northern hemisphere because we are in India and India is in the northern hemisphere. So it is observed on 22nd of December. In this, the southern hemisphere is tilted towards the sun. You see this one here. So towards the sun, this southern hemisphere is tilted. This is equator, this is Tropic of Capricorn. The rays are directly falling on Tropic of Capricorn and major portion of the southern hemisphere is receiving this sunlight. So what happens? In the southern hemisphere, there is more heat and light. So we have summer is there in southern hemisphere. So for northern hemisphere, there is winter. So in southern hemisphere, since summer is there, they have longer days and shorter nights. But we have to take the case of northern hemisphere because of India. So there is a reverse situation and hence we have winter in the month of December. So 22nd December, it has shortest day and longest night in northern hemisphere. Then we have something equinoxes. What is equi? Equi you can say equal. So equal days and night. Here you can say see that some area it is having more half of the day is here, half night is here. This is the circle of illumination actually. So there also it is half day here, half night here, and the poles are tilted. Here the northern pole or the northern hemisphere is tilted and here the southern one is tilted. But in these two areas, and here you have to imagine it to be a 3D figure again. Sun is in the center and this is the position of the earth. So you have to understand that it is revolving like this and the sun is here. So these two figures are properly visible, but this figure you will have to understand that this is the front view. There is a view which is here also, that part of the earth which is here also. Similarly, this is the front view. So there is a part which is on the other side also. This is visible to us, but this part is receiving the sunlight, and here this part is visible to us and receiving the sunlight. So there is another part also beyond that which is not receiving the sunlight. So it is, you have to imagine it to be a 3D figure. Then only you will understand the concept of equinoxes. Understanding solstice is easy because you can see this very properly. Sun right here, sunlight here, dark here, dark here. But if this dark is visible here, the other portion has light also. This other portion which is on the other side, which we cannot show in the figure. And this is the light which is the portion which is receiving the light. So the other portion beyond it is not receiving the light, which is not there in the figure. Now this equinox, the sun's rays fall directly on the equator and north pole and south pole are not tilted and hence they are at equal distance from the sun. So they are not inclined or towards or away from the sun, and hence they have equal day and night throughout the world. So here some part of the world is receiving more, here it is having more day and less night, and reverse in southern. Similarly here also, but here the sun rays are falling directly on the equator. See this line, this black line, the middle line, it is the equator. So it is directly falling. So the entire world is having half of the day and half of the night. See the northern hemisphere, half of the northern hemisphere is day here and the other half which is on the other side is having night. Similarly, the southern hemisphere, this half is having day here and the other half on the other side which is not visible is having night. Here also we can see this night portion here, so of the northern hemisphere. So the northern hemisphere, half of the thing of northern hemisphere is also receiving the sunlight which is not shown in the figure because it is not a 3D image. And similarly, half of the southern hemisphere is here, it is dark, then the other half, which is beyond, if you see it from the inside, then the other half is receiving the sunlight. So the entire earth is having half day and half night, half day here, half night of that hemisphere, then half day here, half night of that hemisphere. So this is only there two equinoxes, spring and autumn. So for northern hemisphere, spring equinox, it is like northern hemisphere spring and southern hemisphere autumn, and the date is 21st March. So we know that in the month of March we have like the beginning of the spring season, then autumn somewhere around September. So the exact date, this is the date where there is equal number of like day and night, the duration is the same, half day half night. So the date is 23rd of September, spring in the southern hemisphere and autumn for us in the northern hemisphere. You can see again the figure, complete figure. This was the case of June, December, then this was of March, this is of September. Dates you can see 21st June, 22nd December, 21st March, and then here 23rd September. Now this was all about this entire seasons and this motion of the earth. I hope you are liking the lessons. If you are doing so, please rate, review, recommend and share. And thank you so much for watching. I'll be meeting you in the next one. There are so many things to cover. Alright, bye bye. Take care. Hello everyone. Welcome to the new lesson on the course, the summary of the class 6 geography NCERT. This is presented by me, Arpita Prakash. You can read more about me here. You can also rate, review, recommend and share the lessons if you are liking them. You can also follow me on Unacademy at this given user link. Now this is the lesson number 4, which is on maps. Okay. Now what are maps? They are the representation, the diagrammatical representation of earth. So when we represent the entire earth in the form of diagrams on paper, this is known as maps. This is done on a flat surface. We do it on a paper. It is like according to a scale, whether it's like a paper or a board or anything, but then we do it on a flat surface. Now this is according to a scale. We'll see scale here, and it includes other features also, and not just the boundary of the earth. I mean, it also includes like continents, like the oceans or the rivers or the plateaus, the mountains, all the other features. Now what is the scale? This is the relationship between distance on the map. Now suppose in map, when you show like the distance between this city and this city is 1 kilometer, you show this on map. But in reality, it is not important that the distance between these two cities will be 1 kilometer only. Why? Because in real life, you know, on the globe or on the earth you say, or on the ground you say, the distance between any two places is very huge, and you cannot show the entire distance, that huge distance on that piece of paper. Otherwise, there is no point of making maps, right? So we reduce that distance on paper to make it like more easy and more understandable. So this is known as scaling. When you reduce the huge distance on the ground to show it on the map, considering the same unit. We will just explain it more when we move ahead in this lesson. Now the art of this example I left, this is like, suppose the 10 kilometer on ground, which is in reality, it is represented as 1 unit on map. That 1 unit can be 1 millimeter, 1 centimeter, 1 meter, depending on how much area you are covering and what kind of map you are making. Now the art of making maps is known as cartography. This term you should remember, and the persons who make maps, they are known as cartographers. Now when we combine or compile many maps or make a book of maps, this is known as atlas. Now the types of maps. First is like general purpose type. The name suggests it is like very general in nature, general use. Then there is information on variety of subjects, and so a single map can cover information about temperature also, rainfall also, crops also and population also. So in a single map, the distribution of all these things are shown. So this is like a very general purpose map. Then there is physical map. What is this physical? Which shows the natural features of the earth, like the mountains, plateaus, plains, rivers, oceans, etc. They are also known as relief maps. Then the political maps, they are the political division. They show the boundary or the political division. So they show things like countries, states, cities, villages. So only the boundary is shown, and these physical maps will show the entire relief, how the mountains are present, where the river flows, and where this plain is there or plateau is there, everything. Now thematic maps, the name suggests it is based on a theme, a particular purpose or a particular information, like a complete map on roads itself. So they'll show the the national highways here and there, so this flow, or the airline connectivity, or the industries, or the rainfall, or the forest. So they will like be based on a particular theme. Okay, now what are the components of a map? The first is distance. In distance we have already seen, again we'll see what is scale, the ratio between the actual distance on the ground and then the distance shown on the map. I have shown you that if there is 10 kilometer distance on the ground, we will not represent that 10 kilometer exactly on the map, right? We will not show it as 10 kilometer. We will reduce it to like 1 millimeter, 1 centimeter, or 1 meter, depending on the situation. Because the small distance on paper, so on paper when we just show a map, it represents a large distance on the ground. Now there are two types of map based on like scale, small scale map and large scale. You have to remember it in a reverse order. The small scale map will show the large areas and the large scale map will show small areas. I'll just explain. When the large areas are shown on map like continents or countries, what will happen? These are the large areas, so they will have like so many, I mean their length will be in huge kilometers, so you cannot express that big amount on the paper. So you will reduce it in the maximum possible extent. You will reduce it to that extent, like you will reduce 5 kilometer on ground to 5 centimeter on map. So you are showing large area in small scale. This is the small scale and this is the large area. So you have to remember like in reverse order. Then the large scale map. So now suppose you have small areas like villages or towns. So their area on the ground is like small. Suppose 5 meter we are showing. So you can consider that 5 meter to be 5 centimeter, but here it's 5 kilometer. So because the areas we are representing are like very larger continents or the countries, but here the areas are very small. So you can have like this small area on a large scale comparatively. So it is large scale map. So just remember this reverse order and you will not get confused. Now the other component of maps is, components is basically what are present in maps. When you read a map and you read an atlas, you should know what are the things present there. So the other thing is like direction. There are 4 major directions: north, south, east and west. So it's like NCERT. So when we combine, it's like news. I hope now you understand what is the full form of news. So it's basically north, east, west and south, covering news of all the directions. And these are also known as cardinal directions or the cardinal points, because they are the main or the major directions. Then there are 4 intermediate directions, which are like northeast, northwest, southeast and southwest. So they are written like this. They cannot be written in reverse order like east north or west north. You cannot just change the name on your wish. They have to be written like this or read like this: northeast, northwest, southeast and southwest. So these are the 4 major directions: north, south, east and west. And then these are the 4 intermediate directions: northeast, which is between north and east; southeast, between south and east; southwest, between south and west; northwest, between north and west. Now you should know the directions. Why? Because it is not only helping in general studies, it will also help you in kind of reasoning questions. There are questions which are based on direction. A moves itna kilometer, x kilometer, and then turns right and left and then moves east and north or northwest. Then what is the final direction from the starting point? So these kind of questions, the reasoning questions, so they are asked. So you should know that okay, this is north, south, east and west. And similar, if you remember the 4 major, you can obviously remember the 4 intermediate also. Between north and east, it is northeast and so on. The next is geographic coordinates. We have seen the latitudes and the longitudes. So they help us to determine the exact location of any place. Now what are the symbols I mean, these are another component. So these are some symbols used which are used to show different features like buildings, roads, bridges. Because if suppose you are showing a building or a road, or for that matter a bridge on the map, so you cannot build that building, I mean draw that building, right? You cannot make that road and or that bridge. So use small symbols to represent them, signs to represent them, so that it's easily understandable. And they are the conventional symbols, that is they are like internationally accepted, so every country is using this, so that there is a proper understanding. Suppose if I will use one symbol to represent a tree and you will use some other symbol to represent a tree, and when we both meet each other and talk and when we discuss about our maps, we will not understand each other's maps, so there will not be uniformity in understanding. So they are like accepted everywhere, so they are the conventional symbols, agreed and then accepted. Now some various colors are used to represent, like blue for water bodies, brown for mountains, yellow for plateau and green for plains. So these are the like kind of symbols used, like for the railway line or the broad gauge or the meter gauge or the railway station, these are used. Then roads and boundaries, and the river, this flowing river, then tank, well. So you can see from here, so for trees this, then grass this, then for graveyard, then for police station they'll write just PS, for church they'll use this, this cross sign. So there are different kinds of things used, symbols used, and they are like accepted for everyone. Then the other thing is sketch. What is sketch? It is irregular drawing which is done without any scaling. So it is not measured properly and then done. It is like a rough drawing, you can say, a rough sketch, like we say in general terms. And this is to know the location. Now suppose you ask your friend that where is your house, and he or she dictates about their home, like they'll just help you understand the location, saying that okay, you start from this point, then you walk certain like 1 kilometer, 2 kilometer, then you will find a temple there, turn right and turn left, then you'll find a pond or something, then there is a shop, then there is my house. So they'll a rough sketch they'll draw on a paper and they'll give you, so that you understand that okay, I have to follow this path to reach to that friend's place. But that is not the exact drawing, they are not measuring or scaling. So that is like sketch, a rough drawing to have the location of any place. Then the plan is the detailed representation. So it is a drawing of a very small area but in a detailed way, okay, and on a large scale. So as the area gets smaller, we have like this large scale plan, and as the area is larger, the plan becomes, or the scaling becomes smaller, because we cannot show large area on similar large representation on paper. Now what is this plan? If I tell you the example of, suppose if there is a construction going on for any like a building or any mall or anything, any school or something. So for that for the construction of that building, they need to have that plan first, where the washrooms will be located, where the parking facility will be located, where the classrooms will be located, where will be the library, where will be the sports ground, where will be the assembly hall and the other things. So depending on that, they are this plan for a smaller area but in a very detailed way. So everything is represented very in a detailed manner. This is one example. So this is like a plan of a school, suppose. So this is the hostel building, this is the playground, this is the indoor stadium, teaching block, lab, park, administration block, parking lot. So they have now explained it, giving the details, okay, that this much area is for this purpose and then near to this is this. So a rough understanding happens, but the plan is very detailed. It is not just a rough drawing. So this was all about studying maps, the lesson on maps. I have some more lessons to cover which are given in the NCERT textbook. So I hope you are liking the lessons. If you are doing so, please do rate, review and recommend. Alright, bye-bye, take care, see you. Hello everyone, welcome to the new lesson of the course where we are covering the summary of the class 6th Geography NCERT. This course is presented by me, Arpita Prakash, and this is something about me. You can also rate, review, recommend and share the lessons if you are liking them. You can also follow me on Unacademy at this given user link to get the regular updates of my courses. Now let's begin. This is the 5th lesson in this course, which talks about major domains of the earth. You are requested to see the overview lesson also and the other 4 chapters also, so that it's easy to link with the coming topics. Now, what are the major domains of the earth? So there are 4 major domains: the lithosphere, atmosphere, hydrosphere and biosphere. Lithosphere is which deals with land, which consists of the land portion. So the solid portion of earth on which we live consists of the lithosphere. Okay, we have the details also of these, all the parts of the domains, but that will be covered in the higher classes, because everything cannot be covered as compared to like class 6th book. So I'm just focusing myself on the content of the NCERT. So just the important key points are given. So the detailed discussions will be there in the senior classes books, and I will be covering that. So atmosphere is air, related to air, where these gases are present, or other gases also. Hydrosphere is the water body, so the area covered by water. Then the biosphere, where the life form exists. Why so? Because if in an area only land is present, or only air is present, or only water is present, you cannot survive. You need all 3 components to have presence of life. This is why earth is known as a unique planet, because all these things exist here. So basically, biosphere is the area or the zone, the narrow zone of interaction of these 3 different zones, so that life exists here. Without their intermixing or without their connection, there cannot be any life in this area of biosphere. So bio is basically life only. So this sphere which has life and consists all interaction of all 3 areas. Then lithosphere, it is the solid portion of the earth. Then the rocks of earth's crust. So I have just told you that lithos, it means like stone or rock, you can say. So the solid portion is the lithosphere, and it also has either the rocks or you can say the soils, and the soil has nutrients which are very essential for the growth of organisms. Then the earth in general, it is like divided into 2 parts, the continents and the ocean basins. So the continents are the large landmass area. So in lithosphere we will cover the continents, and when we talk about the hydrosphere, that is the water bodies, we will talk about the ocean. Then the continents, it is the main landmass of the earth, 7 major continents. So these are the continents. It is in decreasing order of like about the largest, from largest to the smallest. Then we'll study them separately. Asia is the largest continent. It covers about 1/3 of total land area of earth. Okay, it is in the eastern hemisphere. So it is mostly in northern hemisphere also. Northern and eastern, we have studied about it. Equator divides into northern and northern and southern hemisphere, and this prime meridian divides the earth into 2 equal halves, eastern and western hemisphere. So it is in eastern hemisphere, most parts in northern also, and then some parts in southern hemisphere also. Then the Tropic of Cancer passes through it. Please remember that every continent has some or the other latitude passing through it. So you have to remember that which continent has which latitude passing through it. They can ask this question. This can be an MCQ or like by true and false kind of thing. So you should know. These are very basics, but then people might get confused if you don't know the map in your head. So just remember, Tropic of Cancer, Asia. Then it is separated from Europe by the Ural Mountains on the west. So Europe is here, Asia is here. So here is Ural Mountains separating them. And if you combine both the landmass of Europe and Asia, it becomes Eurasia, known as Eurasia. Then Africa, it is the 2nd largest continent. And the equator, it runs almost through the middle of this continent, Africa. So Tropic of Cancer was for Asia, then this equator is for Africa. Now we'll see one more thing. Then the major part lies in the northern hemisphere, and it is the only continent, very important, only continent through which the Tropic of Cancer, equator and Tropic of Capricorn passes. So the only continent. Then the Sahara Desert, which is the world's largest hot desert located in Africa. The Nile River, which is the world's longest river. There is a difference between longest and largest. I'll just show you the other river also. So the world's longest river. So it is in terms of length, right? The distance you can say, or the length of the river. So Nile is the longest river which is found in Africa. Then we have Europe, which is much smaller than Asia, but it is the 2nd smallest continent. It lies west of Asia. We have seen, separated by Ural Mountains, and the combined is known as Eurasia. Then the Arctic Circle passes through it. So just see here, every continent is having a different latitude passing through it. You have to remember the name very thoroughly. Then it is bound by water bodies on three sides. North meets Arctic Ocean, West Atlantic, South Mediterranean Sea. Now, North America, it is the third largest continent after Asia and Africa. It is linked to South America by Isthmus of Panama. Now, see, what is this isthmus? Suppose there are two large landmass like North America and South America. I'm sorry for the map, it is just handmade. So, the two large land masses, North America and South America. So, when the two large land masses are separated by a narrow stretch of land, right, very narrow, very thin stretch of land separates two huge land masses. So that narrow one is known as isthmus. So here the two large land masses are North America and South America, and this narrow stretch is Isthmus of Panama. You must have heard about Panama Canal. So it is here. You while studying these things about maps, you can have, because I don't have time to include slide after every continent because it will take time. I cannot explain that. So you must have your own atlas or any book where these things are present, so you can just relate. I have one map in the end, I'll just show everything together, but then you can also simultaneously do this. You can pause the slide, then see where it is located, and you can do this. Otherwise also we are planning to have a course on maps also, so if that is included, everything will be covered there also, but then you can incorporate it here too. It lies in the northern and western hemisphere, so surrounded by Arctic Ocean in the north, Pacific in the west, and Atlantic in the east. South America, it lies mostly in the southern hemisphere, east में surrounded by Atlantic Ocean, and then west Pacific Ocean. Now the world's longest mountain range is chain of mountains. So it is the Andes Mountains. It is present in South America. Now see here, world's largest river, it is the Amazon River. We have seen that longest river was Nile River, and largest, that is amount of water it carries or the carrying capacity. So by that sense, Amazon is the largest river which is found in South America. But Nile was the longest river in terms of length or the distance. So that was in Africa. Now Australia, it is the smallest continent. It lies entirely in southern hemisphere. It is surrounded on all sides by ocean and seas. So when any land body is surrounded by water bodies from all sides, what is it known as? It is known as island. So Australia is also known as island continent. Now the Tropic of Capricorn, it runs through the middle, so you have to remember this also. And the original inhabitants of Australia, this continent, are known as Aborigines. Then Antarctica, this continent is completely in the southern hemisphere, very southern part. It is a huge continent. It is located in the south polar region. So it is near the South Pole and it lies almost at its center. Now since it is located in the South Polar region, it is permanently covered with thick ice. It is also known as white continent. And since ice is there, no human settlements, and different countries use this place or this continent to set up their research stations. India also has research stations in Antarctica, and different countries also have them. Now hydrosphere, it is the sphere of water. Now Earth is known as blue planet because about 3/4 of the Earth is covered with water, and it exists in three forms: solid, liquid and gases. The running water is found in ocean, rivers and lakes. Then the ice is found in glaciers, and then water vapor is found in atmosphere. So now about 97% of Earth's water, so the total amount of water present on Earth, from that 97% is present in ocean. So that is like saline water that cannot be used, salty water, right? So that cannot be used for your daily uses. So out of the rest water, about 2.5 to 3% water mostly is there in found in glaciers or ice sheets or underground. So for our use, the fresh water, it has very, very, very minimum component or very minimal percentage which is found in rivers or land. So you have to learn what? Not to waste water. We need to conserve water because the fresh water is present in very little amount. So it should not be wasted. Now the oceans, they are interconnected, I have told you, and they are already moving. So what are the types of the main water movements? We will study the details in the senior classes summaries. The book summaries of senior classes books. But then main water movements are like wave, tides and ocean currents. 5 major oceans: Pacific, Atlantic, Indian, Southern and Arctic. Then the Pacific Ocean, it is the largest, spread over 1/3 of Earth, and it contains the deepest part of Earth. What is the deepest part of Earth? Mariana Trench. So it is in the Pacific Ocean. Then it is surrounded by these many continents, you can see here. Then Atlantic Ocean, second largest, it is like S-shaped. Why? Because like North America here, South America here, then Europe here, Asia here, Africa here, so it's like S-shaped. Then it is the busiest ocean when we see it from the point of view of commerce. So when commerce or trade, like when we consider that, so the busiest ocean is the Atlantic Ocean. Then the Southern Ocean, it encircles the continent of Antarctica, and Arctic Ocean is located within the Arctic Circle in the north, near the North Pole. It surrounds it. Then it is connected with Pacific Ocean by a narrow stretch of shallow water, which is known as Bering Strait. So Bering Strait is the name of that strait which connects Pacific Ocean and Arctic Ocean. Now what is strait? So like we have studied isthmus, which is a narrow landmass which connect to larger landmass. So similarly, when a narrow stretch of water body connect to larger water bodies, it is known as strait. Then atmosphere, it is a layer of air which surrounds the Earth. The composition says that about 70% has like nitrogen in the atmosphere. So it helps in growth of organisms. About 21% is oxygen, which is like the breath of life. It is needed for every living organism. And then about 1% has other gases like carbon dioxide, argon, helium, etc. Then the carbon dioxide is needed for the growth of plants. It helps them in the process of photosynthesis. And then it also keeps the planet warm because it absorbs the heat radiated by the Earth. So concentration of carbon dioxide results in global warming, but then a certain amount is necessary so that the temperature is maintained. Otherwise, the planet will become very cold. Now, the layers of atmosphere. So the detail, everything, with the figures and with the detailed description, what happens in each layer, we will be covering in the senior classes. For the time being, just understand that based on the composition or the temperature and other properties, these are the layers of the Earth from the Earth's surface. So if we start from the Earth's surface, the first is troposphere, then stratosphere, mesosphere, thermosphere and exosphere. Now, three important characteristics is like density, temperature and pressure, and each varies as the distance varies. So near the Earth's surface, density, temperature and pressure is high. As we move away or up higher altitude, then it decreases. Now what is atmospheric pressure? It is the pressure that is exerted by the atmosphere on the surface. So atmosphere exerts some pressure on the surface. This is known as atmospheric pressure, and the air moves from the area of high pressure to low pressure. Now this is biosphere, which is a narrow zone of interaction we have seen of all three zones. Life exists here. So mostly the organisms are of two kingdoms, the plant and the animal kingdoms. Now this is the broader map I was talking about, where everything is, whatever we have discussed is summarized kind of thing, not in detail, but then like Nile river we have discussed, Amazon river, this Andes mountains, this Sahara desert, then Himalayas is here, then Ural mountain is here, then these oceans are here, then these are the continents, this is Rocky Mountain, this is Appalachian Mountain, this is Andes we have done already, so this is like Great Barrier Reef, then here it is Tibetan Plateau, so here it is Atlas Mountain, here it is Mediterranean Sea. So more or less here it is Alps mountain. So more or less what you can do is you can understand from here, or just sit with your own atlas and at least mark the places we have covered, like do this Nile river, Amazon river. So at least you will be doing map also together with these things. So this was just for standard 6, so the level was little lower because we had to cover only the important point. The details will be covering as the class goes on increasing. Now hope you are liking the lessons. If you are doing so, please rate, review and recommend. And thank you so much. See you in the next lesson. Bye bye. Hello everyone. Welcome to the new lesson on the course, which is about the summary of class 7 Geography NCERT textbook. This course is presented by me, Arpita Prakash. You can read more about me from here. You can also rate, review, recommend and share the lessons if you are liking them. You can also follow me on Unacademy at this given user link. Now this lesson, it talks about some of the major landforms. See, we have already done some of the major landforms like mountains, plateau and plains in class 6 chapter. Now we'll be dealing with some other kind of landforms, right? So it's like completely different from those landforms. Now you'll see, Now, the different landforms on the Earth's surface, they are created mainly by the process of erosion and deposition. See, we have already covered these three terms, but I'll just repeat so that you understand, because these terms will form the key concept of the entire discussion on this lesson, right? So you need to understand what these terms mean. Now, weathering, it is the breaking up of rocks on the Earth's surface. When the rocks are like broken into smaller fragments, that process is known as weathering. Now, erosion, it is the wearing away of the landscape by different agents like wind, water, etc. So when natural agents like wind, water, they wear away the landscape, that is, they erode the substance from there and then they transport it and deposit it in the other place. So when this wearing takes place, or the breaking, you can say, of this landscape, that they start reducing in size, they are like broken by these natural agents. It is that process of erosion. This is the process of erosion, and after that there is transportation of these eroded materials. So when these are transported, they are then deposited. Like, see here, when this eroded material is carried away or transported by agents, these natural agents themselves, wind, water, whatever, so they are then deposited eventually in some other area. So that process of depositing these eroded materials is known as deposition. However, the process of eroding that material or the wearing away of those landforms, this is known as the erosion. Okay, now we'll be dealing with some these water bodies, or you'll say how this entire river system works. So not much detail, but then whatever is given in the book and whatever is necessary from the point of view of a standard 7th content, we will be dealing with that. So first we will be covering the work of a river. Now we will have to understand that running water, the water which flows normally, it is one of the most powerful agent of erosion. So we have just seen what are the agents of erosion, natural agents like wind, water, etc. So this is one of the most powerful agent, because it erodes, it carries away the material along with it when it flows. Now, what is this waterfall? When water suddenly falls at a steep angle and not at a gentle slope, steep angle over very hard rocks or down a steep valley side, it forms a waterfall. So when water suddenly falls from a great height, in general terms, if I say it is when water suddenly falls from a great height, it forms a waterfall. You'll just see here, water is falling here, these are the hard rocks, and then when water falls here, there are the softer rock which are undercut by the power of the water. So it flows with a very great speed and suddenly, so this becomes a waterfall. Now these are some of the terms which you should know. One is the source of a river. It is the place from where the river originates. We have already done this, but I'm just repeating. Mouth of a river is the place where the river joins the other water bodies, such as seas. So we have done this when we were studying about the Sundarban Delta, right? And then there is a term river basin. It is the area which is drained by river and its tributaries. So this is the river and it has its tributaries here. So the area which is drained by the water from this river as well as its tributaries, that area is known as the river basin. It is also known as the catchment area. This we have seen. Now, one important key word is meanders. What are they? They are the large loops and bends which are formed when the river twists and turns as they enter the plain. Suppose this is the plain. So when the river is entering, they will twist and turn, and the loops which will be formed, or the bends which will be formed because of that, are known as the meanders. I think this figure will explain it. So this green is the plain, the river is entering. So these are the meanders, right? These curves or the bends. Now, there is a concept of oxbow lake also. So before we study this diagram, I'll just show you here. See, this is cropped, so this word is not visible. This is the oxbow lake. You will see that it is separated from this meander or the main river course. So this is the oxbow lake. Now what it actually is and how it is formed, we'll just see. What happens that when this river enters the plain and then starts moving, there is continuous erosion and deposition that is taking place. The river is carrying materials along with it, so it's like erosion, and when it is carrying one material, it is depositing the same material at the other place as it moves along, so that is deposition. Now this continuous erosion and deposition takes place along the sides of the meander. So this is meander. So here you'll see this deposition is taking place here, erosion is taking place here. Some materials are eroded from this area and some materials are deposited to that area. Now, when this continuous process takes place, the ends of the meander loop, they come closer and closer, and they, in due course of time, it is like in due, two different words. So in due course of time, this meander loop will cut itself from the main river and it will form a cut-off lake or the oxbow lake. So it has like cut itself from the main river with due course of time, and this, they are like the forming the oxbow lake. Now I'll explain it in a better sense here. See, this is the meander here, that curve. Now, because of continuous erosion and deposition, it is taking place as the river is moving. So here some part is eroded from here, some part is eroded from here, some part is eroded, some part is eroded. Eroded is basically weathering, or you can say like they are being removed from here. So the height, I mean the size is getting decreased. Here also it is getting decreased. Then erosion is taking place, but then some deposition is also taking place. The river which has carried some eroded materials from the earlier areas, they deposit those materials in this area in near the meanders. So this like deposition here, deposition here, deposition here, deposition here. So with due course of time, what will happen, this will like reduce in size. Here also it will reduce in size, but then here it will like increase in size, and it will slowly cut out itself. The main river will start flowing like this. See, the main river will start flowing like this, and this area with gradual erosion and deposition, it will become separated and it will form a separate this kind of thing, this shape. Because of the shape, it is known as oxbow lake. So this will form a separate area. So it is happening because of continuous erosion and deposition. So you can see here it has now separated itself from the main course. The river is now following this course, and it is the oxbow lake. The name is not visible, but it is the same thing. Now, floodplains. So how are they formed? These floodplains, they are formed by the deposited alluvium. Alluvium are basically the soil or the other sediments like the sand silts, you can say. So they are formed by the deposited alluvium, and they are relatively the flat region. So when river overflows, what happened? They flood the neighboring areas. The river is like overflowing, so the neighboring areas get flooded, and when they get flooded, they deposit layers of fine soil or sediments, which is known as alluvium, along its banks. So when they are flowing along their banks, they deposit some layers of this alluvium, and hence the floodplains are formed in the flat region. Now one concept is of levees, which is when many floods happen, when continuously this flood is happening, this floodplains are being formed, then the deposits which are near the river channels, they pile up along the banks of the rivers, right? So there are some deposits near the river channels as because of the flood plain formation. So these deposits will now start get piling up along the banks of the river, and they will form a raised embankment. They will pile up, they will be raised, and they will form another kind of embankment. That raised platform will be known as the levees. Now we have a concept of distributaries and tributaries. See, there is a difference between these two words. Tributaries is basically when a main river is flowing and some smaller rivers are joining them. So those smaller rivers are the smaller streams are known as the tributaries. Now this is distributaries. This is when a smaller stream into which a river is broken. That is, a main river is going and it is getting broken into smaller streams. So those smaller streams are known as the distributaries. However, when smaller streams join a main river, that is tributary. Now what happens? When the river approaches the sea, the excess load that it is like carried by the river is now deposited at the mouth of the river. Mouth of the river, where the river joins the other water body. So these loads are like deposited there, and when we collect the sediments from all these mouths, it forms a delta. We have already learned about the Sundarban delta. Now you see, this is the main river, and they are like broken into different distributaries, and then this region forms a delta. Then we have the work of sea waves. This was the work of river. This is about sea waves. So in coastal areas, there is erosional and depositional work is also done. So in coastal areas, these works are performed by sea water. In the normal areas, it will be like done by the fresh water, the flowing water of the rivers. But in the coastal areas, it is done by the sea water with the help of sea waves. So it results in the formation of coastal landforms. Now what happened? when sea waves, they continuously strike the rocks, there are cracks which are developed in those rocks, and when these cracks, they become larger and larger or wider, there are some hollow structures or hollow caves created on that rock. Suppose this is a rock and sea waves are hitting it, so it will gradually get eroded and the rock part here, and the cracks will develop, and then the cracks will become more large and then wider also. So it will become like hollow, like caves will be formed on these rocks. These are known as the sea caves. So we'll just see here. So this is the sea caves, this is the rock here, and sea waves are like hitting it, so a cave kind of thing is formed here. Then after the formation of sea caves, what happens, that the cavities, they start becoming more big, right, because of the continuous hitting of the rock by the sea waves. So with gradual this hitting, this cave becoming more there is like more cavities are developed in these sea caves, then only the roof of the caves will remain after some point of time, and it will be like complete hollow kind of thing, and only the upper part, the roof, will be left. Then sea arches are formed. You'll see sea arc here. See, this is the sea cave. So only it's like being hit, and here a cave structure is formed. But then by continuous hitting, it's like hollow, right? So you can like just cross through this, and only the upper part is left. So it becomes sea arc. You see, it's a better picture here, right? So it's like completely hollow. Then after sea arcs are formed, there is further erosion, and now the roof is also broken. Earlier only the roof remained, now the roof is also broken, and only walls are left, right? So these walls like structures or the features are known as the stacks. So you can see after continuous erosion, only the stacks or the wall like structures are left. This roof is like broken. This is the sea arc. Then there is a concept of sea cliff. Now when waves crash against a high rocky coast near the base, now you'll see, now this is the entire, that was the rocky coast, and when the waves like they start hitting this coast, what happened near the base, right? So it is like happening near the base of the coast. So the rocks will now get eroded near the base, and with passage of time, what will happen, the rocks above that hollowed out part will collapse, and it will leave behind the steep wall of rock which will face the sea. So this is the sea cliff. So here you can see the broken part. Here it was like there. So continuous hitting will finally make it collapse, and then this cliff will remain which will face the sea. So this is the sea cliff which is facing the sea. This is the broken part. Now work of ice. So what are glaciers? They are the rivers of snow and ice, and they move out very slowly. Now the main work of a glacier is transportation, erosion and deposition, and they also carve out deep hollows, and when the ice melts, they get filled up with water. So these hollows, they are like made by the glacier, work of the glaciers, they are carved out by the glaciers. So now when the ice will melt, these hollows will be filled up with water, and they will become beautiful lakes in the mountains. Then these glaciers, they also carry some materials like rocks, sand and silts, and they deposit them. So these deposits from the glacier is known as glacier moraines. This is the glacier, huge like combination of, or the reverse of, you can say, snow and ice. Then the work of wind. What is wind? It is the active agent of erosion and deposition in the deserts, and they erode the lower part of the rock more than the upper part. So lower part is important, and this gives the rock a shape resembling a mushroom. So the rocks are also known as the mushroom rocks. Now what are sand dunes? When the wind blows, it lifts and transports sand from one place to another, and when it stops blowing, the sand falls and gets deposited in low hill-like structure which are known as the sand dunes. So these are the sand dunes. Now what is this less? When sand grains are very fine and light, they are carried over long distances and deposited in large areas. So they are known as less. Now the time was less, so I had to do it faster. I hope you have understood. If you have not, you can ask your doubts in the comment section. This was all for today. Thank you so much. Bye-bye. Hello everyone. Welcome to the new lesson on the course, which is the summary of Class 6 Geography NCERT. This course is presented by me, Arpita Prakash. You can read more about me from here. You can also rate, review, recommend and share the lessons if you are liking them. You can also follow me on Unacademy at this given user link. Now, this is the 7th lesson in this course of the summary of this book. The lesson is about our country, India. Okay, these are the some of the important facts we will discuss about India, and then we will proceed to the other things. Okay, India is the 7th largest country. How? By land mass. The criteria is land mass. It is the 7th largest country. Please name the first 6 largest countries in the comment section below. It is also the 2nd most populous country. So, population wise, India is the 2nd most populous country after China. It is like about 2% of the world's land mass. So, India has it contains 2.4% of the world's land mass, and in terms of population it is 17.5% of the world's total population. Total area of India is about 3.28 million square kilometer. The population according to census 2011 is 1210.9 million. Now it is in the northern hemisphere. The earth is divided into northern and southern hemisphere by the equator. So, India lies in the northern hemisphere, and the Tropic of Cancer 23, which is having a 23.5 degree north latitude, it passes through almost half of the country. So, if this is our India, this Tropic of Cancer almost divides it into half. Then the latitudinal extent of India is 8 degree 4 minute north to 37 degree 6 minute north. Longitudinal extent is 68 degree 7 minute east to 97 degree 25 minutes east. Now, the north-south extent, this is the length, which is 3214 kilometer. So, this north-south extent is this much kilometer, and east-west extent is 2933 kilometer. Now, for India, this we have already done, that 82 degree 30 minute east is the Indian Standard Time, which is along the standard meridian of India. So, along this standard, this is our standard meridian of India, 82 degree 30 minute east, and along this meridian, the time is Indian Standard Time. Now, we have 29 states and 7 union territories, and area wise, the largest state is Rajasthan and smallest is Goa, and our capital is the National Capital Territory of Delhi, NCT of Delhi. Now, this is the figure. So, see, this is the longitudinal extent, 68 degree 7 minute east to 97 degree 25 minute east, and these are the latitudinal extent, 8 degree 4 minute north to 37 degree 6 minute north. So, we can see that we are starting from like 8 degree 4 minute, and the equator is at 0 degree. So, India is in the northern hemisphere. Now, the length you can also see, this north and south, it is 3214 kilometer, and then east west extent is 2933 kilometer, and then it is the standard meridian at 82 degree 30 minute east longitude. Now, we will study about the physical divisions broadly speaking, and I will just be covering the major details because the entire proper coverage is done in the senior classes books. So, the physical divisions, we are doing this 6th thing: the northern mountains, the northern plains, the Great Indian Desert, the peninsular plateau, coastal plains, and the islands. Okay. Now, the northern mountains. So, when we talk about Himalayas, it is like Him plus Ale. Him is snow, and Ale is like a place, or you can say home. So, it is Himalaya is basically the abode of snow. So, you know Himalaya is covered like with thick ice. So, that is why the name is given like this. And when we talk about the northern mountains, we talk about the Himalayas. So, it has like 3 parallel ranges. We have studied that the range is the chain of mountains, the 3 parallel ranges. The first is, the uppermost is the Himadri or the Greater Himalayas, and the world's highest mountain peak, which is Mount Everest, and it is located in Nepal. So, it is forming a part of this range of Himalayas. Then the next one is Himachal or Middle Himalayas, or also known as Lesser Himalayas. So, this different hill stations like Shimla etc., they are located in this region, and they also have Dhauladhar and Pir Panjal ranges. Then the next Himalaya, the range is the Shivalik or the Outer Himalayas. So, they are the southernmost range. This is the first one, this is the next one, and this is the southernmost, and this is also, so the name has come from like Shiva Alex. So, it is the abode of Lord Shiva. So, the name is like this. Then the northern plains, and I am repeating, this is just the brief description, right? So, it is based on the class 6th book. The content which is given there, I am just covering from there. It is not the detail. There is so much to study in these physical features. So, it will be covered as we move along with the classes. Okay, the northern plains. It is one of the largest alluvial plains in the world we have done, which is formed from alluvium. Then it lies south to the Himalayas. So this is the Himalayas here, and then the northern plain is here. This is leveled and then flat. This is formed by alluvial deposits. The rivers deposits which are brought by the rivers Indus, Ganga, Brahmaputra and their tributaries, and it has like fertile land which is very good for cultivation and agriculture purpose. Then the Ganga and the Brahmaputra rivers, they form the world's largest delta, which is known as Sundarbans Delta. Now we will see what is delta. It is triangular in shape and it is a landmass which is formed at the mouth of a river. So first of all, what is mouth of a river? It is a place where a river joins the sea. So if a river is coming and a sea is here, so at this place the river is joining the sea. So this is known as mouth of the river. So a triangular shaped landmass which is formed at this point or this mouth of the river, it is known as delta. So this Ganga and Brahmaputra river, they form the world's largest delta, which is known as the Sundarbans Delta. Now the Great Indian Desert, it is located in the western part of India. The Thar Desert, the name is the Thar Desert, located in the state of Rajasthan. So this western part of, here is the Himalayas, here is the plain and here is the desert. So it is dry, hot, sandy. It is a stretch of land which has very little of vegetation and very scanty rainfall, but is because it is like completely desert area. And east of it is the Aravalli range. We will see in the map. At the end I have a map in which I will be covering all the things, because it's very difficult to show map after every slide because of the time constraint. But when we deal with these topics in greater detail, I will be covering along with the maps itself. So you will not have to wait for the last slide to see the map. Or you can also pause the slide here, you can have your own atlas or the book and you can keep referring to the map. Otherwise, I'll just show at the end. Now the peninsular plateau, it is in south of the northern plains. So here was northern plains, here was desert, here was Himalayas. So this is the plateau area. This is triangular in shape. And what is peninsula? It is that area of the land which is surrounded by water on its three sides. So Indian peninsular plateau is surrounded by water on three sides. On the west, Arabian Sea, east Bay of Bengal, and in the south the Indian Ocean. Then the north is the plains here, Himalayas here, deserts here. Then the northwestern side is the Aravalli range, and it is one of the oldest ranges of the world. So here it is Aravalli range, here is the desert, and this Aravalli range is the one of the oldest ranges of the world. Now the peninsular plateau is divided into two parts, the northern plateau and the Deccan plateau. Northern plateau is again divided into Malwa and Chota Nagpur plateau. So this Malwa plateau is between the Aravalli and the Satpura ranges. We will just see in the map when we come across that slide. So the Malwa plateau is between this Aravalli range and Satpura range and the Narmada valley. So here is river Narmada also flows. So that valley has also this range, Vindhyas range, in this plateau region. Then we have this Chota Nagpur plateau which is east of Malwa plateau, somewhere here, okay, in the states of like near Jharkhand, Chhattisgarh. So they are separated from Ranchi plateau by river Swarna Rekha. So Malwa plateau is here, Chota Nagpur plateau is here, and this was whole of northern plateau. Then we have this Deccan plateau which is south of Narmada. So the Narmada river is here where there is Vindhya range, and south of that is the Deccan plateau which is separated from Malwa plateau by the Vindhyas. Then we also have this concept of Ghats, the western Ghats and the eastern Ghats. It is also included in the physical features of India. These Ghats, they border the plateau, west side also and east side also. So if this is India, this is the plateau region. So we have western Ghats here and eastern Ghats here. So the western Ghats, they are almost continuous, but the eastern Ghats are uneven and broken. So the western Ghats are also known as the Sahyadris. Then we have this coastal plains. So on the west side of the western Ghats, there is this western coast. Okay, this is narrower. So this is western Ghat. Then here we have western coast. And on the east side of the eastern Ghat, we have this eastern coast which is comparatively broader. And then the east flowing rivers like Mahanadi, Godavari, Krishna and Kaveri, they make deltas on the east coast. We have already read about one of the delta, the Sundarbans Delta, formed by the river Ganga and Brahmaputra. So these rivers, they also make delta on the eastern coast because they flow east, so they make deltas here. Now about the islands. So in India we have basically 2 islands, Andaman and Nicobar and the Lakshadweep. So Andaman and Nicobar is located in Bay of Bengal. So if this is India, this is Bay of Bengal here, Andaman and Nicobar Islands here, Lakshadweep in the Arabian Sea here. Then this capital of Andaman and Nicobar is Port Blair. For Lakshadweep it is Kavaratti. Then the Lakshadweep Islands, they are like the coral islands. What is coral? It is the skeletons of tiny marine animals called polyps. So these polyps are the marine animals, small little marine animals which are like found in the water bodies. So when these animals die, their skeleton is left, and when all these skeletons are like piled up, so it forms coral island. This Lakshadweep is coral island. Then this Andaman Nicobar Island, it is the southernmost point of Union, in the Indian Union, which is the Indira Point. It is located in the Andaman and Nicobar Islands, but this Indira Point got submerged when there was a tsunami in 2004. So it is now submerged, but it is often asked that which was the southernmost point of the Indian Union. So you have to remember this name. It is Indira Point. Now this map I was talking about, we will just see what all things are here. See, first we have this Greater Himalaya, then we have Shivalik. So I told you we have the parallel ranges of Himalaya. So it is here, this entire green, here it is the plains. So the northern plain, you will see this Ganga river here, this Brahmaputra here. So there you will have this Sundarban Delta. And here it is the Great Indian Desert, then the Aravalli range here, one of the oldest ranges. Then we come to this plateau area. So here it is the Vindhya ranges, here is the Narmada river, here is the Satpura range, and here is this Deccan plateau, here is the Chota Nagpur plateau, here is the Malwa plateau here. And this is, see here, this is Western Ghat, this is Eastern Ghat. Then we have surrounding these ghats the western coastal plain and the eastern coastal plain, this one. So we have covered mountain, plains, desert, this plateau, this ghat, this coastal plains. Now what is left is the islands. So here in Bay of Bengal we have Andaman and Nicobar Islands, and here in the Arabian Sea area we have the Lakshadweep Islands, and this is the Indian Ocean. So you can have your own map also, you can see them in greater detail because this is just one map covering everything. And also I will be dealing with all the details when we talk about these physical features separately. We will have like a complete proper different lessons on each physical feature, because we will have to describe the minute details of these features. This was just a kind of introduction because it is mentioned in the book. So I just restricted myself to the content from the book itself. Alright, I hope you are liking the lessons. If you are doing so, please rate, review, recommend and share. You can also watch the other lessons, and please do watch the overview lessons. So see you in the next one. Bye bye. Thank you. Hello everyone. Welcome to the new lesson on the course, which is the summary of class 6 Geography NCERT. This course is presented by me, Arpita Prakash. You can read more about me from here. You can also rate, review, recommend and share the lessons if you are liking them. You can also follow me on Unacademy at this given user link. Now, this is the 8th lesson which talks about India, the climate, the vegetation and wildlife. Then, the first thing we are dealing with the climate. Again, I am repeating, I had already requested you please watch the overview lesson, then only proceed to the other ones. But then this is just the important points from the content of this class 6 book and not the details on these issues. They are very important issues and they are to be dealt in greater depth and detail as we move along with the senior classes. Alright, so just the key points. Then climate. Now there is a huge difference between the terms weather and climate. Many people often tend to confuse between them. You should not. So just see what is the difference. Weather is the short term atmospheric conditions. So it is like short term atmospheric conditions like heat, moisture and how they move, how the transfer of heat or moisture takes place. So all this, but for the shorter term period. So that is like weather. But climate is the average of atmospheric conditions. So these atmospheric conditions like heat, moisture, etc. So when we take the average of these conditions which are measured over a longer period of time, say about 20-30 years, we see a pattern that okay, this region has this type of climate. So when it is like first of all it's the average, and then it is like taken over a longer period of time, then it is climate. If it is for shorter term and for a shorter duration of time, the movement of these conditions, then it is the weather. Now, when we talk about seasons, there are 4 major seasons that are basically recognized in India. The first is the cold weather season or the winter season. So, in this we have low temperature because the sun's rays do not fall directly in the region. So, the southern, India is in the northern hemisphere, we have done that. So, the southern hemisphere receives heat of the sun and the rays of the sun. So, they have summer there, and so we have winter at this point of time because we do not get the sun's rays directly. Then the month is when the winter season is there, it is usually from December to February. Then the other season is the hot weather season, which is the summer season where the sun rays falls more or less directly on the region. So it is like kind of mostly vertical rays, and even not vertical, but then we have slant but proper rays falling in our region or the northern region. So we have this summer season or the hot weather season, and we have high temperature. One of the characteristic feature of this summer season is the loo, prevalence of loo. What is loo? It is the hot and dry wind that blow during the daytime during the summer season, the months from March to May. Then the southwest monsoon season or the rainy season. So it happens when there is onset and advance of monsoon, and the winds, they blow from the Arabian Sea and the Bay of Bengal towards the land. So what happens, because of this blowing of wind, they carry the moisture along with them. So when these winds which are carrying this moisture, they strike these mountains, rainfall takes place. So usually the month for this rainy season is June to September. Then the next season is the season of retreating monsoon or the autumn season, where what happens, the winds move back to the water bodies and then the rainfall takes place in this southern part of India, particularly in the states of like Tamil Nadu and Andhra Pradesh. The rains take place because these winds are moving back to the water bodies. So the months are like October and November for this retreating monsoon or the autumn season. Then broadly, when we say that India's, if in one word you are asked what is India's climate or what type of climate is there in India, so we say that we have a monsoon type of climate. Now this word monsoon is derived from the term mausim, which is an Arabic word. So the meaning of this word is season, and the meaning of this word monsoon is the seasonal reversal of winds. That is, in different season the wind changes its direction. I mean, seasonally the winds reverse. So if it is coming from here, then it moves like this. Now India is in the tropical region, so most of the rain, it is brought by the monsoon winds. There are some factors, broadly speaking. We also have the details of this factor again in the senior classes. So the factors that affect climate are location, the area like the tropical or the subtropical, equatorial, what kind of region the place is located in. So based on the location, we have the difference in climate. Then altitude is height, then the distance from the sea, and then the relief features. Relief is basically the difference in the elevation of different landforms like the mountain, plains, plateau. So they have difference in the elevation, so they are known as relief. So because of the relief structure also, we have difference in the climatic conditions of different areas. Then it is about natural vegetation. We had 3 headings in this lesson: the climate, the vegetation and the wildlife. So this is the natural vegetation. Now what is there? We also know that in our surrounding, it is like a variety of plants are there in our surrounding, and these plants basically form, this plant community basically forms this natural vegetation thing. So the plant community which has grown naturally, natural vegetation, you can make out from the name itself, so which has grown naturally, and it is like without the human aid or influence. So that is natural vegetation, and we are not talking about the flowering plants or something which we use them in our garden, you know. Those are the done by the human aid or influence, but we are talking about the natural forest or the natural vegetation, and they are left undisturbed for a long time. They grown naturally, not by human interference, left undisturbed for a long time. Some examples of the kind of plants which are found in the natural vegetation is like some bushes, which are the small plants, some shrubs like the cactus, then some tall trees or the grasses. So these are the variety of plants. Then climate is the dominant factor which influences the vegetation. We also have other factors. It also depends on the location, the altitude and everything, but the major factor is the climate, because then climate is itself determined by the other factors. So here the major the major factor we are considering is the climate. So based on that, we have some divisions of natural vegetation. We will see some types of forests. What are they? The first is the tropical rainforest. So we can like from the name itself, we can understand that it is located in the tropical region. And then rainforest. So the rain takes place in these forests. Now what are the characteristic features? They are in the heavy rainfall area. They are very dense. Because of more rain, the growth is very good. So they are like very dense forest, and they are so dense that the sunlight through these trees or through these forests, they does not even reach the ground. So they are like trapped within the leaves of the trees itself, because they are so dense. And then the trees do not shed leaves in a particular season. They do shed leaves, but at different points of time. So whenever you look at these forests, they appear to be like evergreen, because at a particular season, all the leaves are not shed by these forests. Some examples: mahogany, ebony, rosewood, etc. And then some location: Andaman Nicobar Islands, parts of northeastern states, then the narrow strip of the western slope of the Western Ghat. So we have read about it. The Western Ghat is here, so narrow strip here. Then the next is the tropical deciduous forest. They are less dense as compared to the evergreen one, and they shed their leaves at a particular time of the year. So all the leaves are shed at one particular time of the year. They are also known as monsoon forests. Why? Because the leaves which are shed at this time of year, they start arriving when there is arrival or the onset of monsoon. So they are also known as the monsoon forests. Some example of trees like sal, teak, peepal, neem, shisham, etc. And some areas in India: MP, UP, Bihar, Jharkhand, Chhattisgarh, Odisha, and some parts of Maharashtra. Then third type of forest is thorny forest. We can again understand from the name itself. Thorn is the needle kind of thing. So they are found in the dry areas, so basically in the desert areas, and the leaves are in the form of spines. So they are the thorny forest. Why? So that there is less water loss by the process of transpiration. If the area of the leaf will be more water will be lost. So if they have like needle or spine or this thorn kind of thing, there will be less loss of water. Example: cactus, khair, babool, kikar, etc. Some areas: Rajasthan, Punjab, Haryana, and some eastern slopes of the Western Ghats and Gujarat. Then we have mountain vegetation. They are found in the mountains, and they changes with the height. So with different altitude, we have like different kind of vegetation. And here in these kinds of vegetation, what happens? With increase in height, there is fall in temperature. So it's colder in the higher altitude, and it's comparatively warmer in the lower altitude. So what happened? They are also known as the montane vegetation or the alpine vegetation, and they have in some of the, so with like change in height elevation, they have different types of I have just told you that the changes with height, so they have like different types of vegetation. So one kind of those vegetation is also known as coniferous trees, because they have conical shaped, like cone shaped trees. For example, fir, pine, deodar, etc. So they are known as coniferous trees. Then the next is the mangrove forests. They are also known as tidal forest. They can survive in saline water, fresh water also, but then saline water also. They are mostly found in the Sundarbans, the delta which was formed by the river Ganga and Brahmaputra. We have studied. So in the West Bengal area, in the eastern area, they are mostly found, and also in the Andaman Nicobar Islands. So one important tree species of these mangrove forests is the Sundari tree, and on this only the name Sundarbans was kept. So these Sundari tree, they provide durable wood which is very good for making boats. Now we come to some importance of forest. They release oxygen, so they help us in breathing. This is the main important component of life to survive here. Then they also helps in like carbon dioxide absorption, because it helps in the process of photosynthesis. So what the carbon dioxide that we release, humans release, they absorb it, and then they release oxygen in return, which we consume and we use for breathing. Then the roots of the plant bind soil, so there is less of soil erosion, and hence there is proper vegetation or the growth. Then it also provides these forest products like timber, fuel wood, medicinal plants, honey, gum, etc. They are the natural habitat of wildlife. They stay there, I mean they live there, and they also helps in rainfall because the soil is bind, so it also helps in conservation of trees, and hence there is more more amount of rainfall. Then for conservation of these natural vegetation, some kinds like movements like Chipko movement were used, where people used to hug the trees and they stopped the others from cutting the trees, and programs like Van Mahotsav to plant more and more trees. Then about wildlife, so they are basically the animals that live in the forest or in the natural vegetation area. Some varieties of species of animals which are found are like reptiles, which like crore, snakes, lizards, etc. Then the amphibians, which live both on land and water, like frogs, etc. Then the mammals, which give birth to young ones. Then the birds, the insects, worms. So these are some of the species. There are variety of species. Then the national animal for us is tiger. The national bird is peacock. Then the Asiatic lions are found in the Gir forests of Gujarat. Then in the forest of Assam, what species of animals are found? Like elephants and one-horned rhinoceros. Then in Kerala and Karnataka also elephants are found. Then the camels, they are found in the Great Indian Desert, and the wild asses, they are found in the run of Kutch area. And in the Himalayan region, what kind of animal species are found? Wild goats, snow leopards, bears, etc. Then some other birds like parrots, pigeons, myna, bulbul. These are some bird species. Then among snakes, we have like cobras and kraits, etc. Then some of the programs for conservation of wildlife, they are used. They were like in place, like Project Tiger, Project Elephant, Project Rhino, etc. So these programs were used to conserve the wildlife. So this is the same slide. I just had to crop it here. It somehow did not happen. So this is the same thing. So these are the program used for the conservation of wildlife. So we need to conserve our natural vegetation as well as wildlife, because they are, first of all, they add to our heritage also, and then they are like very important for the survival of human beings also. If their number reduces, it disturbs the ecological balance. So we should work towards conserving them. Alright, so I hope you are liking the lessons. This was all for this entire course. This was the last lesson. Thank you so much. Keep watching the other courses too. Bye bye. Hello everyone. Today I am just adding a section on the course which we did yesterday about the summary, NCERT summary of classics geography book. Because of one fellow aspirant, he just pointed out that there was some misclarification regarding the concept of IDL, that is international date line. So I just thought that I'll do it again, so that if there is any kind of problem in understanding the concept, you can have it. So like this is done on a very urgent basis right now, so you might face some noise problem also, but please just bear with that because I had to do this urgently. Alright, okay, this is the clarification on the international date line. I'll just repeat, but then I have just tried to present it in a better way. The content is the same. I'll just try to explain it in a more better way so that you understand. Now, this is the thing which we did about IDL. It is an imaginary line, yes, and it is internationally agreed, yes, all the countries agree to this. Now what happens to, and the location is 180-degree meridian. Now what happens is, this line is very important. Why? Because when you cross this line, there is a change in the date. Alright, there is a change in the date and not in the time. Why so? Because see, if this is the time zone, this we have already done, that the earth is divided into 24 time zones of 1 hour each. Alright, so if this is the time zone, the ideal is located in between that time zone. So the zone is same, so the time remains same, but the date changes. As you cross this line, there is a change in the date. How this happens, I will just show you. And there are some deviations in this line. It is not like straight line like the other longitudes. This is because it has to accommodate the some of the islands which are present through which it passes. Like if it will pass in as a straight line, it will also create problem, the day problem for the people who are inhabitants of those islands. Like in the northern side, in the northern Pacific, the Aleutian Islands of Alaska, and in the southern Pacific, the islands of Fiji and Tonga. So those people will face problem as soon as they cross this line, because there will be a change in the day. So just to accommodate them on one side, this line is made to pass through the water body, so that and that is like, because of that only there are deviation. Now what happens in ideal when we move from west to east, right? This is west, this is east. When we move from west to east, there is gaining of a day, and when we move from east to west, there is loss of a day, and this happens while crossing ideal. How it happens? See here. This figure we saw yesterday, but there was some confusion regarding this figure itself. The concept was the same, but some confusion. So I'll just try to clear that. See, this is 0 degree prime meridian, right? And opposite, first of all, you have to imagine that this is a globe. I have presented it on a flat sheet of paper, but you have to consider it to be a globe or a round body, right? Or a ball kind of thing. So suppose if this front is the 0 degree, and this whole is like a round body. So this line or this line is the exactly opposite of this 0 degree, right? So that is like 180 degree. So when we move from this 0 degree to 180 degree, it becomes 180 degree east meridian. And this is like located the opposite side of this, the opposite, right? Please try to imagine that. And when we move from this 0 degree to 180 degree west, it becomes the 180 degree west meridian, right? But in practical, this or this is the same, just the direction matters. So when we move from here to here, it becomes 180 degree east. When we move from here to here, it becomes 180 degree west. Now what happens? Now again you will have to imagine it to be a globe or a circle. So this is the front view or the 0 degree meridian view, alright? Now the area, this portion, which is like here presented on a flat sheet of paper, the area between 0 degree prime meridian or the 180 degree east, that is the international date line, will, if suppose this is a round body or a globe, so this area will actually become the western side of this line. Please, just pause this slide, this video here, and try to understand this. If you consider it to be a circle like this, and this is the front line, so the back line of this is this 180 degree line, but then the area between this 0 and this 180 degree east is actually the western part for this line. Now, so you have to relate it like this. I have not, like, this direction is not wrong here, but then if you consider it to be backward here, you will figure it out. So if this is the line, and when we say that the line, like when we move from west to east, so if this is that line which is at the back of the 0 degree, and when we move from west to east, so this portion is the west. So when we are moving from west to east, we are actually moving like this, right? This is the same line, so we are like crossing it like this. So then there is a gain of day. How it is gain of day? At this line it will be 2nd of January. And when we cross this line, and like it becomes this only, because these two are the same line, just the direction matters. So it becomes 1st January. Now how is it a gain of a day? You will say that the date is reduced, a day is reducing. So how it is gain? It is gain in the sense that if you, at this line, the day is 2nd of January, and when you cross it, you get the day 1st of January. So you have already lived that 2nd of January. But now when you come here, 1st of January, sorry. When you are here at 2nd of January, that means you have already lived that 1st of January. That one day you have already lived. But if you like come here, so here it is 1st of January again. So you get another day, one extra day to live again, which you have already lived here, but then you gain one day. So the gaining concept is this, that here the day is this and here the day is this. The time is the same because of the time zone. So the day is here 2nd January and here it's 1st January, but you are gaining it in the sense that you have already lived this 1st January when you were here. But when you cross this line and come here, you are again getting a chance to live this day. Alright, so in that sense it is gaining a day. Now when it comes to losing a day, how it happens? So again, the area between this 0 degree prime meridian to 180 degree west international date line. Okay, so for this line, this is the eastern area, right? So when we move from like east to west, so we are like moving from here to here. So the day changes from 1st of January to 2nd of January. Now what happens? How do you lose a day? You were here on 1st of January, right? And suddenly when you cross this line, you get 2nd of January. So you do not get a chance to live this 1st of January. That is missed. You suddenly will have to live this 2nd of January. So there is a loss of one day, and here it was gain of one day. Hope that this losing and gaining of day is clear. When you gain a day, it means that the day decreases in that sense. Decreases, it becomes from 2nd of January to 1st of January, so that you get another day to live. That is gaining of a day. You are in the profit. You have already lived that day here, but then when you come here, you get another chance to live that day. And losing of a day means the day changes from 1st of January to 2nd of January. This is because you have already you were supposed to live 1st January here also, but then since the day here is 2nd January, you miss out on living this day, that is the 1st of January. So there is a loss of day. So you will have to understand that this is a circle, like a globe or a sphere, and this is the front and this is at the back. So this 180 degrees is the back, and this area between this and this is actually the western side of this line. So when we move from west to east, it means that we are moving from here to here, right? This is the west. So you will have to consider that. Please try to imagine and then understand accordingly. Alright, so this was just for the clarification. I hope you have got it clear now. If still there is some confusion, you can ask in the comment section. Thank you so much. Bye bye.